saved fuel, we've increased production. The kiln does have near the upsets. There's basically no temperature excursions. The mud is ramped properly, to less shock for the kiln.
Well, it's being accepted by the operators. Has a good uptime.
We've seen upwards of 90% reduction in variability on the operation of the kiln.
And most importantly, it's giving us a payback, and more than enough payback to cover the cost within a year.
At today's natural gas prices, the percent reduction range from 5 to 15% equates to a savings of between $250,000 and $750,000.
Canadian Forest Products, known as Canfor Corporation, is Canada's largest producer of softwood lumber and market pulp. Canfor's Northwood pulp mill in Prince George, British Columbia, relies on natural gas from external suppliers to fire its huge lime kilns as part of its recausticizing process. To reduce gas consumption and operating costs, Canfor needed a way to operate the kilns more precisely, more efficiently.
The lime kiln is a very difficult process, a unit process, because of the interaction between all the different variables you're trying to control.
Depending on the individual that come in, he would have his idea on the ramping rates, and that would change. There would be kiln upsets as a result.
4 crews, 4 different theories of how they're going to operate, and unfortunately that gave inconsistency in operation.
In the temperatures, there was excursions on both the feed end and hot end controls. With the multiple fuels that we burn, alone or with one another, the rates, it would start to chase themselves. It would just go out of control. It was always back into the manual mode.
Canfor wanted an advanced control solution to better control the kiln operations. But where could they find a solution they could easily operate, maintain, and modify?
They were all black box solutions. We would not own the code. We would not have access to the code. Anytime we need to make a change, we'd have to rely on the vendor to come in and support us.
Canfor found its answer in DeltaV Predict, part of the advanced control applications in the DeltaV digital automation system from Emerson Process Management.
The DeltaV is a very open system, easy to implement controls and maintain. And we felt that with this option we'd be able to maintain the controls on our own once the system was in place.
It wasn't a black box. That was one of the things that really caught their eye, plus the ease of use and maintainability.
Another factor is the fact that the controls programs, the DeltaV solution reside in the DCS system, where it can take full advantages of the robustness and reliability of the DCS system, as opposed to an application computer, which is much less reliable.
And what my expectations were was to hands off. Basically, the computer is going to represent the best of the operations, and they only intervene when forced to, and we have one consistent operation, and that's what we were looking for.
For Canfor, the savings began with the automation system's installation.
The installation of the equipment took just a matter of weeks, and the final commissioning of controls took less than a week, and it's been running ever since.
But what about Canfor's main goal of reducing fuel consumption?
We're already seeing savings that range from a very conservative estimate of about 5% reduction in energy fuel up to 15% or more. At today's natural gas prices, the percent reduction range from 5 to 15% equates to a savings of between $250,000 and $750,000.
And the payback to Canfor for its automation investment?
Using the more generous numbers, which we expect to achieve, it probably brings us down to about a 3-month payback.
We've actually made a recommendation to go forward on the A kiln on the same predictive controller. I'm pretty sure that we'll move in that direction because we've got a payback that would justify doing it, even though it's not a budgeted item.
Applying DeltaV Predict on the lime kiln not only saved fuel costs, it increased Canfor's production capacity while reducing waste.
As we started to put more and more parts of the DeltaV online, and there was definitely an increase in production rate.
One of the drivers that I saw of this project was it would stabilize operation, and optimizing and stabilizing operation immediately impacts on this type of system the amount of product that is termed as waste product. Any way that you can stabilize the operation, you can reduce the impact that you will have on the environment.
We'll be able to reduce our operating temperatures and still produce an optimum product. Since DeltaV has been operating, we've seen a reduction in variability in all of our process variables associated with the kiln of about 90%. This will allow us to push the operation of our kiln closer to the edge.
In fact, it's closed the variability of both the back end and feed end temperatures.
So what are the paybacks from those dramatic reductions in process variability?
Since we've been running on full control, we have decreased our energy substantially, and we have increased the kiln throughput also by probably around 15–16%. It's running consistent, and the ramping capabilities are really, really good as far as mud feed rates.
One of our major concerns is brickwork, and ensuring that that brickwork maintains its integrity and doesn't have to be replaced often. If you can maintain kind of a very stable temperature gradient across your kiln, your life cycle or life expectancy of your brickwork is better.
Well, what the DeltaV has done for us is made our kiln control more consistent throughout the different operators. Everybody runs it the same. Everybody has a little better understanding of kiln theory. It's on almost 100% of the time. It's on MPC control.
The side benefits of not having different changes, we've had massive buildups in that kiln. Now, the predictive controller is not the only thing we've done, but basically we shut the kiln down about a month ago and it's as clean as a whistle, which is an indication of consistent operation.
Fuel cost savings, higher throughput and production, reduced variability, longer operating life, and easier operation.
It's really, really easy to operate it. Once it was online operating, it's essentially hands-off.
Now what we've done with DeltaV Predict and the lime kiln solution is we've simplified it for the operators so they can run their kiln as a unit and not as a collection of independent control loops.
It seems like you have to pay a lot less attention to it. I'd make a little adjustment here, or I'd make a little adjustment there. Now it's, you look over, oh, kiln made a little adjustment on its own.
They have a validation tool in there that's just excellent that we used on the project to check our models against other historical runtime data to see how closely it predicts the process response. It's all one nice application. I was impressed that we could take the models that the Predict application generated on the lime kiln and just download them as they were without having to modify them.
I guess I'm really impressed with its simplicity, the simplicity of this equipment and its ability to do what you need to do with a lower upfront cost, but with more ability later to kind of manipulate and change and make it do what you want it to do. I'm quite impressed with it.
And how do Canfor's operators respond to an automation system controlling the multiple variables they once controlled?
With this control strategy, the new DeltaV, we've been able to bring all the operations groups together, and we've got now a supervisory computerized program that is running 95+, 97+% of the time that is giving you a stable product, and the operators have bought in.
It took a little while for everyone to buy into it, but once everybody has bought into it, now it's on, it stays on, it just runs.
They now see it as not a package that takes control away from them, but as a tool that they can feel comfortable with. It just allows the operator to enter set points and trust that the control system is going to maintain those set points.
Canfor saw robust operation in the model predictive controller running in DeltaV.
And I was especially pleased with and surprised with the robustness of the controller. In the 3.5 months that we've been running DeltaV Predict, we've seen an uptime of about 98%. And most of the times that it was not running was due to upsets in our operations, conditions that the controls cannot possibly deal with.
It's made my job easier. We've had other controller guys come in here before and try and set things up, and it seemed that you know, as long as everything was really, really perfect, it would run perfect. But as soon as we had an upset before, the controller would lose it. But this one seems to have, it catches all the problems. It seems to catch little upsets. It catches blips in fuel flow. It runs really, really well.
With these results, Canfor is looking at other mill areas to implement the DeltaV system and its advanced control applications.
We are looking at taking another project on and moving this same control system into our A line kiln.
Now that we're happy with DeltaV Predict on our B line kiln, we're hoping to use DeltaV Predict on other processes in our recost area.
To run the kiln on MPC is basically hands-off. It just runs by itself. It runs beautifully. It seems to be the general consensus of the whole department.